Alright guys, here is a little help for DCP23. It's the St. Louis Arch. We've talked about the arch a little bit in our notes before. We were finding the actual measure of the height of this arch using similar figures before. We used a similar triangle with this one. With the shadows, we measured the shadows and we made our proportion, and then we figured out that the arch was about 630 feet tall. Right straight from the middle straight to the very tip, it's about 630 feet. So suppose Eduardo is taking pictures of the monument such that the top of the arch is at an angle of 68 degrees with his line of sight. So here's my Eduardo. I drew a little stick guy. And it says sketch a drawing to model the situation. You may use the picture here on this paper. So what we want to do is we want to draw a picture from Eduardo up to the top. And we want to come straight down. And that gives us a right triangle right here. So let's put that in there for us. We got our right triangle. We know, the pieces that we know is that this is 630 feet. So that's a given information to us, 630 feet. We also know that, let's see, what else did it tell us? That Eduardo is taking pictures and such that the top of the arch is at a 68-degree angle. So 68-degree angle from his line of sight. So he looks up at a 68-degree angle to see the top of the monument. So that's the kind of picture you would want to draw. Now I really hope that you guys try these before you watch these videos. I hope you guys give it a shot and kind of just use these videos to check your answers to see if you're doing it right, to see if maybe you've got the picture right and if you're on the right track. So letter B, how far is Eduardo standing from the base of the gateway arch? So what I'm here to do is help you set it up. You are looking for this X right here. Okay, this is our X. We're looking for the X that takes us from Eduardo to the middle of where the arch would be. So let's see. Here to here, basically. So that's what we're trying to figure out. This distance from Eduardo to the base of the arch, where we could drop down an altitude of 630 feet, round to the nearest tenth of a foot. So in this drawing, this is the angle we need to use. This is our angle that they've given to us. From this angle, if you look straight across, you get 630 feet. That represents what we call the opposite side of 68 degrees. Okay, so it's opposite of 68 degrees. Okay, so that's what this side here represents. This side down here represents the adjacent to 68 degrees. Okay, so that's the, so we're looking, they gave us the opposite and we need the adjacent. So those are the two sides that are in play. This hypotenuse right here is not even in play. We don't need the hypotenuse, and they didn't give us the hypotenuse. It's not something we need. The only reason it's there is because it makes a right triangle. We have the opposite, we need the adjacent. That means from our trig functions, when we're talking about SOHCAHTOA, sine is opposite over hypotenuse. Well, I don't need hypotenuse. Cosine is adjacent over hypotenuse. Again, I don't need the hypotenuse, so I don't need either of those two. What I do need is I have tangent, and I'll have the opposite, and I need the adjacent. So it's got to be TOA. I got to use tangent because I have opposite and I need adjacent. So here's how you would set it up. You would put tangent of 68 degrees, and then you would put equals tangent of 68 degrees equals, and then you would set up your fraction of opposite side, 630, over the adjacent side of x. Opposite over adjacent, you always use your TOA, T-O-A. You can do opposite over adjacent, and let me just put that up here, opposite over adjacent. Just so you know how I got the TOA, T-O-A, TOA, tangent, opposite, adjacent. Tangent 68, 630, x. 630 is opposite, x is adjacent. Now we got to just solve for x. You could put a 1 under this and cross multiply. You could just multiply both sides by x and then divide both sides by the tangent of 68. You could plug tangent of 68 in your calculator right now and get a decimal, put a 1 under it, and multiply your diagonal, or your diagonals. I mean, there's a plethora of different ways that you could solve this equation. There's lots of ways. You, with your Algebra 1 skills, should be able to solve that. If you don't like to see a tangent of 68, then get rid of it by plugging it into your calculator and get a decimal. Round it to like the nearest 3 or 4 decimal places, and then use it as a proportion. So lots of different ways that you could solve this one, but that's the equation that you're going to need. So that's here, you're going to find x. Now it says when Eduardo stands 100 feet from the base of the arch, what angle will his line of sight be when he looks at the top of the monument? So if he is 100 feet away, what we want to know this time is the angle. So this time we have to do tangent -1. We are looking for the angle. They did not give us the angle. And so in our calculator we hit the inverse button or the second function button, and then we hit tangent, and then we put the opposite side, 630, and we divide it by the adjacent side of 100. And I don't think I really like it like that as much. So tangent -1, let me do this. 630 divided by 100. That's what's going to go into your calculator when you plug it into your inverse function. You're going to hit the tangent or hit the inverse button or the second function button, and then hit the tangent button. That's going to give you this tangent -1. Whenever you see tangent -1, that means you're looking for an angle. You're not looking for a side anymore. You're not looking for an x as far as a length. You're looking for an angle. And so I'm just going to put it like this so you can see that this division problem goes inside of the parentheses here. Another one of these, and I'll flip it around. Okay, so that goes in there. So you're going to hit the tangent -1, put this division problem in the parentheses, hit equals, and you should end up with a new angle. Now, if he's farther away, the angle should be less. I'm just giving you a hint there. If he was to get closer, he would look up higher, and the angle would be more. As he gets farther back, because he's now 100 feet back, we don't know what he was back here, so maybe it would be more. I don't know what this x is, so I didn't solve it. So if this is less than 100 and he's backing up, then the angle is gonna be smaller. If this is more than 100 and he's moving into 100, then he's gonna look up higher. So I'm gonna give you gauge your answer on this one to see if you're right. That's how that goes. All right, hopefully that helps, and we'll see you guys later.